Alrighty, we are on week 1, question 13. Malcolm is downloading a file that is 50 megabytes. It's 50 megabytes. His internet connection has a download speed of 1.2 megabytes per second. Let T represent the amount of time in seconds it's going to take to download this file. Okay, so let me show you something real quick. Whenever I see the word per, that is going to be, just tells me I'm doing a multiplication problem. So it's 1.2 megabytes per second. So let's go ahead and think about this. That's not how you spell the word second. Let's go ahead and think about that word per. So what if I told you, I'm going to give you a random example. What if I told you that I ate 5 candy canes per day? I ate 5 candy canes per day. So how many candy canes would I eat in 2 days? Well, most of you guys would say, well, easily 10. And I would say, well, how did you get there? And you would say, okay, well, you would just multiply however many per day, but it's for 2 days, so you multiply it times 2. All right, so it is per second. So let T represent the amount of time. So we know that we're taking this 1.2 and we are multiplying it to T. So we are multiplying it to T because I already told you that it's 1.2 per second. Let T represent the amount of times in seconds it will take to download the file. So even just knowing this information, knowing that I am multiplying 1.2 to the letter T, I can go down here and eliminate without even solving. So letter A, this 1.2 and T are smashed up next to each other. That is a coefficient in a variable. They are being multiplied. So that can automatically be my answer. I don't even have to solve this. You just had to know that the word per meant to multiply. I know I'm not dividing, and I know I'm not taking my total megabytes and subtracting time, and I know I'm not adding them together. So again, with all of this, you can just use that word per, and it means to multiply. Next one. Match the variable expression to its numerical expression. Again, we're numerical. Okay, the quotient of a number and 20. So we need to know what that word quotient means. So we used it in a previous example. So the word quotient means to divide. So we're going to go on in here and, oh, there's a division. So this matches up right here. A number increased by 20. So let's think about this example. What if I told you that I have, I don't know, I'm really in the mood for candy canes. So let's say I have 10 candy canes in my pocket. Well, that number just increased by 5. So how many candy canes do I have in total? You would say, well, 15, because you add them together. So increased is connected to the word that has to do with addition, which is there. 20 less than a number. So this is where it's going to get tricky. 20 less than and 20 decreased. Okay, so if I told you that I have 20 less than however many dogs you have. Well, maybe not dogs, books. Let's do books. So I have 20 less than whatever you have. I don't know how many you have. Am I going to take the amount of books you have and subtract it from 20? Or am I going to take 20 and subtract it from the amount of books that you have? So this would line up a lot better because this is 20 less than a number versus this one, the number 20 is being decreased by a number. So we're starting with 20 like we are here, and you are decreasing it by a number. Okay. Question 15. Right. There are a few powers of 2. So, oof, powers. What in the world are we talking about? So these are exponents. So when we have an exponent, we are talking about our base, and it is being multiplied to itself however many times the exponent tells it to do so. So for this one, 2 to the 6th power is 2 times 2 times 2 times 2 times 2 times 2. That's how they got 64. 2 to the 5th power is 2 times itself 5 times. That's how they got 32. 2 to the 4th power is the base times itself, however many times the exponent says. So that's 2 times itself 4 times. So this one is 2 cubed, or 2 to the 3rd. So I'm going to do that over here. So that would be 2 times 2 times 2. 2 times itself 3 times. So let's go ahead and do the 2 times 2 first, which is 4. Bring down that 2. Then 4 times 2 is 8. Do another one. 2 to the 2nd power is pretty easy. That's just 2 times itself 2 times. So 2 to the 2nd power would be 4. That's 2 times 2, which is 4. 2 to the 1 power is, you only write the number 2 one time because that's what the exponent says. So that's it. You don't even have to multiply it to anything. It's just the number. And then this is just a rule of algebra, and I know it's been a while since we learned this, and it's okay if you don't 100% remember it. Anything raised to the 0 power is 1. It could be 1 gajillion. I don't even know. Raised to the 0 power, that's the number 1. Doesn't matter. Anything raised to the 0 power is 1. Again, if you don't have that memorized, it's okay. All right, question number 16. Select the equation with the solution of n equals 15. So what that means is I'm going to take this 15, and I'm going to plug it into everywhere I see an n and see if it's true. All right, it's going to take some work. So let's do this first example. 4 plus, I'm not writing n, I'm writing 15, equals 11. See if that's true. 4 plus 15 is 19. That is not true. So that one's not going to work. Let's try this one. 5, now this one is just 5n, and you're like, well, how are they connected? Well, that's our if you have a number and a letter smack up next to each other, your little coefficient and variable, they are being multiplied. So that is 5 times 5 equals 70. Oh, I'm sorry. I'm so sorry. It is 5 times 15. Sorry. Equals 70. So I do not know that off the top of my head. I'm going to go ahead and write that over here. 5 times 5 is 25, and 5 times 1 is 5, so that's 75. So does 75 equal 70? No, that's not true either. Okay, let's try this one. Instead of the letter n, I'm writing the number 15. 15 minus 6 equals 9. 15 minus 6 is 9. Hey, that works out. That's true. So that one would work. What about, I'm going to plug in 15 here. 15 plus 8 equals 24. So let's see if that's true. So we have 15 plus 8, and that is 5 plus that is 23. Ooh, that's not it. That one will not work either. And then your very last, oops, sorry. Sorry, and your very last one is that 90 equals 6. That dot means times 15. Well, I don't know that off the top of my head, so I'm going to go ahead and write that over here. 6 times 5 is 30. 6 times 1 is 6, plus 3 more is 90. Hey, 90 equals 90. That is a true statement. So it would be these two. Question 17. This is the exact same process. It's just we're plugging in the number 5 now. Now, if you ever have these little squares instead of circles, there are multiple answers. I'll tell you that right now. Excuse me. All right, so let's go ahead and give this a try. I am going to take this number 5 and I'm going to put it wherever I see an x. We're going to turn all these x's to the number 5. So we're going to have 3 equals, instead of 2 times x, it's going to change to 2 times 5 minus 7. So we have to use our gems. We know that multiplication comes before subtraction. 2 times 5 is 10, and I'm just bringing down that minus 7. Try not to do more than one step at a time, okay? Don't just do one tiny step. So then we have 3 equals 10 minus 7, which is 3. So that is a true statement. So when I plugged in 5, I got the right answer. All right, let's try another one. So I'm going to try this one over here. 18 equals 6. Instead of times x, I'm going to change it to a 5 minus 12. One step at a time. Just plug it in first. And now let's do our multiplication first. 6 times 5 is 30 minus 12. Now 30 minus 12 is 18. Woohoo! That one will work. And then let's do one last one, which is 3 equals 2 plus, I'm not putting x, I'm putting the number 5. 3 equals 2 plus 5, which is 7. That is not true. So that one's not going to work. Okay. I think this is going to be our last one for our video. Pretty sure. Yeah. Maybe. We'll see how we get. So this is a cute triangle, and it wants to know the length of CD. So when you have this line on the top of it, it means the side of it. So all it's asking is see where C is, and you see where D is. It's talking about this side. How big is it? Well, when it's on a graph, it's super awesome. All you have to do is count. So it's 1, 2, 3, 4 blocks long. So your answer would be 4. Super cool. All right, this one is exponents again. So it's our base times itself, however many times the exponent is, 4. So we have 2 times 2, which is 4. And then 4 times 4 is 16. Look at that. We're doing great. All right, last one. This is a net of a 3-dimensional figure. All right, so that means these pieces are going to fold on up to make a 3D figure. I will tell you, we can go ahead and look. The base is going to tell you what kind of pyramid it is. So it is not a square pyramid because its base is not a square. Okay. It's definitely not a rectangle. This definitely is not going to have a rectangular shape. So these two are a little bit different. So this is going to be a triangle. The way I remember it is that a triangular prism, if you've ever seen that candy, it's like Toblerone or something. I don't know. It looks like this. It's like a triangle that's just been really stretched. That's what a triangular prism looks like. Versus a triangular pyramid would be folded up. And it looks like this. Oops. Okay. So it is a triangular pyramid. Woohoo! So we fit them all in this video.